Yeah. Our next talk is by Kumar Anirudha, who's a product architect, open source builder, and an individual independent researcher. And it's a very interesting talk on why your next server might be a browser. So, yeah, the stage is all yours.
Thank you. For some reason, this is not sticking, so I am Anirudh. Sure. Is this even working?
See, there's no speaker, but it's capturing your voice for me.
Okay.
You need to speak loudly.
Sure.
There are all people that want to listen to you, even if they're standing.
I think there's a couple of seats there.
It's going to fall off. You can probably keep it.
I've like 20 minutes, right?
Yeah, you have to. Close the door.
All right.
Everyone, please maintain silence.
All right, let's start. How many of you know about WebAssembly? Okay. How many of you have worked on, like at least like compiled something and ran something on WebAssembly? A few. Okay. Awesome. The talk is we're going to discuss about WebAssembly and essentially how that can change how you are currently developing your softwares, how you're currently running them, testing them, so on. My name is Kumar Anirudha. I build some open source projects, I maintain some open source projects, and also I work as a consultant for some of the companies in product building and so on. If you think of the browser today, mostly what you would see is that you would want to run some client-side softwares, and that is what that is mapped in our heads, right? Like for example, if you have to do anything on the browser, you have to write like some JavaScript, some HTML, and that will run on the browser. From there, you can connect it via APIs or something, and then your backend can be sort of anything. It can be Python, Rust, Go, C, Ruby, whatever. Where we are, and right now your backend is currently running on somewhere in the in some containers, or it's running naked on some servers, or and so on. That is like the general architecture that we follow today. The idea is that we don't associate browsers with like very heavy runtimes. We essentially don't even burden our client side with a lot of like processing stuff. We move everything to the backend. And that's how the distinction is, because browsers essentially, if you keep a lot of things on there, like it used to be in terms of, let's say, Java Spring or something, it will be like a very heavy thing that will start loading on the client side. It will make things a lot slower. Today, we have like machines which can take up a lot more processing than we used to. So even if you put like a lot of processing power on the front side, it still might work out, right? But it doesn't really have a lot of capabilities to run all the processes, let's say scripts and so on, still. That's where WASM comes in. Now, what WebAssembly says is that essentially what you had with the assembly language, which runs on your systems, which understands which your native computer system server understands, with WebAssembly, you can have the same near native speed processing on the browser now. Right, and the browsers comes with a native WASM VM now inbuilt with JavaScript's V8 engine. It's inbuilt in there, and even if not, you can essentially load a WASM VM on the browser side. Even on the server side, there is a WASM VM that you can run. A lot of folks, I think, they also use WASM VM in Cloudflare workers. So even when things are like unsupervised way, you can still work around with WebAssembly. The advantage that you get is it's again very sandboxed. So anything that you run is again pretty much safe unless you open up the ports or something. These are also like the advantages and right now also the challenges, because there is very less interfaces which allow you to interact with your WASM code with your machine stuff. You don't have access to file system, you don't have access to your HTTP network, you don't have access to a lot of things with WASM. But that's where we are currently working on, and a lot of research is going on. So you can essentially write your program in any language, be it Rust, C++, Python also to a certain extent is supported. JavaScript is not directly supported, but there is a subset of JavaScript called assembly script, which is supported. So anything that can be very strongly typed is supported right now. They have compilers which can compile things to that. And for this, and for those who don't have, there are some projects which are working around with the compiler part. So essentially, that is the goal with WASM, is that there is no OS dependency. You can run anything on, let's say, a WASM VM. And that's the same idea with any container. You write your code in any language, you run it on a Docker container, it can essentially run anywhere, right? It's not just, it runs on my system. And the same concept with WASM. So you can essentially run an entire Linux on the browser as well. And that's really how things are evolving. So if you want to look at this is a dummy project that I made. I can actually show it. So what this does is that this will load an Alpine Linux. Alpine Linux is obviously the smallest Linux that you can find, Linux distro. But it's essentially loading on our browser, right? And this is all inside this sandbox WASM VM itself. There's nowhere outside that it can interact. It cannot even interact with your system's stuff. So if you want to query something on there, it will not work unless you add something like WASI or something, which is like a WASM system interface, and then it will sort of work. So this is essentially loading all the modules of your Linux, whatever it is. So it's booting up, and once it boots up, you can essentially use it. We can wait for it to boot up, but if you want, this is a simple project on my GitHub. It's open. If you want to try it out, you can. WASM VM Linux terminal, and yeah, we'll let it boot up for a while. And that's where we essentially are going. So if you can run an entire Linux, you can think of the possibility that you can do on your browser itself. You can run your servers in there. That's where a problem comes in with the runtime of the WASM, because you can't essentially work on packaging everything together and then working through what compiler to use, what runtime to use, how to deploy it, and so on. So we're working on this open source project called WASM Run. It's also open source on the GitHub. And think of Node for WASM, right? Like before that, server-side JavaScript was extremely difficult to do. You'll have to run it through a lot of steps. But with Node, now you can just do Node and whatever JS file or project, and it will just run it. With WASM Run, it's sort of similar things that you get. I'll just show a very quick. So this is basically the Linux that is up, and yeah, all the commands of basically with the supports with Alpine Linux will essentially work here. Now let's see. Okay, just close this. So WASM Run is obviously available on a crate. It's written in Rust. So if you want to contribute to it, and you're most welcome. So you can install it with cargo install WASM Run. I'll just run a local copy of it, yeah. So let's say I want to run a simple Rust hello. Here's a simple example. And when you run it, this will essentially first compile it. This works on a AOT compiler base, which is ahead of time. We can essentially support just-in-time compilers as well, but AOT works very well because of the compiled languages. Okay, there is some issue right now, but essentially this is a console part where you can run your commands. We have a generated playground, which right now it's not loading, and some modules which will essentially load here. I'll check up on the bug. This is a very actively worked project, and I was working on it last night as well, so maybe I switched around some things. Okay. And that's essentially what WASM Run is. So let me just try to do this. So the current release version is 0.11 something, and 0.12 I was working on. So maybe there's something I messed up on 0.12 last night. So hopefully 0.11 works still fine. Wasm supports a plugin sort of architecture, and we are not going to discuss the architecture today, but essentially you can, some are built-in plugins and some are you have to install. So the Rust and Go plugins I have exported out to make it like a external plugin. So you'll have to install if you want to run Rust or Go-based projects. All right, A is still giving some error. Anyway, this is how it should have run. I'll check up on the error and get back. But essentially, that should make it like a lot more easier. What we can also do with Wasm Run is inspect if there is any issue with the generated Wasm file. So right, and this will show us like exactly all the. I did not realize it's a dark screen. Is it visible? All right. So essentially, it will tell you like what all the like what is the size of it, what are the exported and imported functions of this that you can use when you're running this. And yeah, if there is some possible issues, it will try to mark up this. Okay. That's more or less it about like how you can run Wasm Run. This is more from a development perspective. When you're deploying, you won't need this. All you have to do is just put up your .wasm file somewhere and keep it running. And essentially, if it's a browser, then you can just so everything loads on the client side, right? So once you share this, when people open this particular link, it will load up all the things on their browser. If it's a entire Linux that you're shipping, you have to. Entire Linux shipping might be a little bit troublesome because you have to also you have to load the complete ISO file from distro and everything like we just saw. If you can do that, then it will essentially load everything. If not, there'll be easier ways to do it with Cloudflare workers and so on, which essentially will have it deployed somewhere. It's still when you're still compiling, it just compiles a lot more than you need, but a lot of active research work is going on in this, which tries to make everything very compact and smaller in size. So hopefully we'll have a point where this works as seamlessly as right now your Docker works. So the future of Wasm is something. So it should have looked like this, where it will load all of the modules, right? And so this is still like sandbox, and we have to load the WASI, which gives us access to the system interfaces for it to actually work on. So WASI has some modules, which is like a file system module. It has a clock module. It has access to your network and so on. And you can essentially turn off and on these modules as per your need, right? And yeah, because this is a plugin-based architecture, if you have a particular plugin that you want to add, you can also add it and just try to run it with Wasm Run. It will just work fine. The goal of this project is to create a modular architecture for Wasm's ecosystem. So essentially, if you have a Go project that you want to compile to Wasm, you want to distribute that. If you have a Rust project that you want to compile to Wasm, you want to distribute that, Python project, and so on. From the end user perspective, they can just import whatever they want and make their project work. So we can essentially turn our browsers into a complete dev environment. So if you had to take away like a few key takeaways from this session, I think it would be like browsers are not just for JavaScript and TypeScript. You can actually run anything and everything on it. Containers have a lightweight rivals right now with Wasm Run. It's not as painful as it is, although we saw some errors in there, which is somewhat painful. But hopefully, once this works perfectly fine, it will not be. So you can rethink your dev environments in a very different way, in which you don't have to be constrained with just JavaScript, TypeScript for your browsers. You can actually run anything. If you see the front-end technologies today with Rust, there's Leptos and U and Dioxys and so on. These help in like running an entire front-end framework with less or very less JavaScript involved. But still, we need some JavaScript because a lot of packaging right now is done on the interpretation on the runtime side. So there's still some amount of friction there, but hopefully those things will go away. And that's about it. If you have any questions, we can cover those. I think we all. Yeah.
You can keep that to answer.
Okay.
Next speaker.
Internally, Docker uses, I think, the Linux concepts of namespaces and C groups to virtualize. I'm struggling to understand how Wasm is exactly able to virtualize.
Sorry?
I'm struggling to understand how Wasm is able to virtualize because Docker is just using the underlying OS itself to virtualize.
Yeah. So with Wasm, it doesn't give like an entire OS, but you can load whatever you want in it. Essentially, you can think of if we want to just load, let's say, the node packages, right? So you can just load the node packages without having to run the entire OS itself. And that's how I think some of the projects, like say, Figma and all, right? They all run on completely Wasm. So it loads whatever modules it needs onto the Wasm VM, and then it runs. It doesn't need the entire OS. But if you need the entire OS, and in some cases you will, in that case you will have to add like the interface modules with WASI or something else. Or you can essentially load the entire Linux like with Alpine Linux or something, some lightweight stuff.
Thank you.
Hello Kumar. So my question is, what features does Wasm run provides? Like, let's say if you are saying this node, it's just like a node in JavaScript world. So node provides FS support, then fetch API support. Then what does Wasm provides as a feature?
So the node analogy I gave for Wasm run as a runtime, Wasm you can think of like just the compiled version of it, right? So it won't provide anything by itself. It's just a compiled version. But whatever you can run, like which your interface allows, or your system or your language what your allows, it can probably run. So any functional level stuff, you write it on your language side, which is in Rust, Go, any language that you choose to write, C, and so on. Any interface level stuff that you need will be provided either by external modules, like for example WASI. WASI is currently probably the interface modules that it provides. I don't think anything else is there. So using those, you can get access to the other things. But from a language functional perspective, you have to rely on whatever language you want to go with.
Okay, got it. So I guess.
Other than Figma, what are the big examples of applications that are getting built with that you see?
I'm not sure over the top of my head, but I think a lot of projects from Google also runs on Wasm. A lot of games runs on Wasm. I think there will be a lot of examples if we just look. I think there is also some LLM projects which runs on Wasm now. There's a web container from Stagblitz which runs on Wasm completely. Some static sites now they are building with, they're also running on Wasm. Yeah, a bunch of projects are there now.
Thank you.
So like you just mentioned static site rendering, right? So let's say if Next.js wanted to use Wasm, so basically instead of building in the server side, we can build it in the front end only, in the client only, right?
Yeah, so essentially Next.js is like, okay, yeah, you can run the entire thing like server side and front end, right? So it doesn't need to change its own framework. It just needs to change where it's running.
Oh, okay, got
So it can run the entire, like the full stack on the browser in the Wasm VM directly.
That's exciting.
All right. Thank you so much.